At the end of this video, you should be able to summarize the 5 essential points of Dalton's atomic theory and explain the relationship between Dalton's atomic theory and the law of conservation of mass, law of definite proportions, and the law of multiple proportions. Chapter 3, Section 1, Dalton's atomic theory. In 1808, an English school teacher named John Dalton proposed an explanation for the law of conservation of mass, the law of definite proportions, and the law of multiple proportions. He reasoned that elements were composed of atoms and that only whole numbers of atoms can combine to form compounds. His theory can be summed up by the following statements. 1. All matter is composed of extremely small particles called atoms. 2. Atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in mass, size, and other properties. Number 3. Atoms cannot be subdivided, created, or destroyed. Number 4. Atoms of different elements combine in simple whole number ratios to form chemical compounds. Number 5. In chemical reactions, atoms are combined, separated, or rearranged. According to Dalton's atomic theory, the law of conservation of mass is explained by the fact that chemical reactions involve merely the combination, separation, or rearrangement of atoms, and that during these processes, atoms are not subdivided, created, or destroyed. This idea is illustrated in Figure 3-2 on page 67 of your text or on the screen now. For the formation of carbon monoxide from carbon and oxygen, shown in A, an atom of carbon, C, and an atom of oxygen, O, can combine chemically to form a molecule of carbon monoxide, CO. The mass of the CO molecule is equal to the mass of the carbon atom plus the mass of the oxygen atom. In B, the reverse holds true in a reaction in which a carbon monoxide molecule is broken down into its constituent elements. The law of definite proportions, on the other hand, results from the fact that a given chemical compound is always composed of the same combination of atoms. As for the law of multiple proportions, in the case of the carbon oxides, the 2-to-1 ratio of oxygen masses results because carbon dioxide always contains twice as many atoms of oxygen, at least per atom of carbon, as does carbon monoxide. This can also be seen in Figure 3-3 on page 67 of your text or on the screen now. In A, carbon monoxide molecules are always composed of one carbon atom and one oxygen atom. In B, carbon dioxide molecules are always composed of one carbon atom and two oxygen atoms. Note that a molecule of carbon dioxide contains twice as many oxygen atoms as does a molecule of carbon monoxide. Modern atomic theory. By relating atoms to the measurable property of mass, Dalton turned Democritus's idea into a scientific theory that could be tested by experiment. But not all aspects of Dalton's atomic theory have proven to be correct. For example, today we know that atoms are divisible into even smaller particles, although the law of conservation of mass still holds true for chemical reactions. And as you will see in section 3.3, we know that a given element can have atoms with different masses. Atomic theory has not been discarded, however. Instead, it has been modified to explain these new observations. The important concepts that 1. All matter is composed of atoms, and that 2. Atoms of one element differ in properties from atoms of another element remain unchanged. At this point, you should be able to summarize the 5 essential points of Dalton's atomic theory and explain the relationship between Dalton's atomic theory and the law of conservation of mass, the law of definite proportions, and the law of multiple proportions.